Can you hear me? Oh. Can you hear me now? Yes, okay, cool.
Okay, everyone, we're gonna get started.
Hi. Okay, cool. Thank you all for coming to our first in-person, but our third ever SURG Symposium. As you can see, we have a lot of really cool research projects that we have for this semester, and we're so excited to share them with you all.
So who are we? We are SURG, the SDG undergraduate research group, and we're guided by the UN Sustainable Development Goals. So SURG is a fairly new organization. As we said, this is our third symposium, but we are affiliated with the Office of Sustainability. This year, we joined the Sustainable Development Solution Network as part of a youth organization. And we are also affiliated with the University of California's Office of the President Carbon Neutrality Initiative this semester. So the plans and the goals of this organization is that it's a student-led project mentored by faculty with the goal of collaborating to develop a research report at the end. And now this is our symposium to present it to the broader community. Slide, please.
And so these are some of the goals that we really want to emphasize and focus on as a group, really making sure that we're researching cross-cutting sustainability issues that are intersectional in nature, but also relate to environmental initiatives, making sure that we empower undergraduate voices and make sure that we offer these increased accessibility of what research means on campus.
So we have 25 student researchers across 6 different research committees, all focused on 17 SDGs so far. So we're really excited to get started. Cool. So Strawberry Creek Management, can you please come up?
Hi everyone, so we did a research project this past semester on Strawberry Creek management. So I'll let introduce ourselves.
I'm Sydney, I'm a first year here.
I'm Nicole, I'm a senior. I'm Emma, I'm a sophomore.
Ben.
You can like split.
So you're talking to the camera and I can.
Yeah, okay. Okay, sorry. But yeah, and I'm Meg and I am a second year. And our project, before we begin, we just wanted to acknowledge our lovely mentors, Dr. Sasha Harris-Lovett, who I think is attending over Zoom, and Tim Fine, who's sitting right here. And this project was definitely very, very influenced and shaped by the guidance of our mentors, and we're very, very grateful to them and all of the help that they've given us these past few months. So yeah.
Next slide.
Yeah, please.
Okay, so the Strawberry Creek Management Committee aims to analyze past and present relationships between Strawberry Creek's management, water quality, and ecology. UC Berkeley has done a commendable job of restoring Strawberry Creek water quality and ecosystem services since the 1980s, but total chlorine levels are lacking in active monitoring and management, which results in ecological consequences for the creek. Our goal was to identify point sources of chlorine input and relationships between chlorine input and irrigation runoff. We were able to analyze the data and understand how past creek infrastructure projects and decisions, as well as current campus lawn irrigation practices, have led to chloramine concentrations present in the creek.
So some of the sustainable development goals that our project focused on were SDG 6, which is clean water and sanitation. And this this SDG shaped our project by talking about how some of the relevant targets were integrated water resources management, aquatic ecosystem protection, and engaging local communities. So by focusing on Strawberry Creek and management practices related to like our chlorine that ends up in the creek from the irrigation on campus and like the sprinklers on the campus lawns. So how we can like better manage that, as well as like protect our like a creek and the ecosystem, as well as engaging the community in like awareness and education about this issue. And then also related to SDGs 11 and 12 about, again, the sustainable management of natural resources, but also promoting awareness of sustainable development within our community. And then again, with SDG 11 about sustainable cities and communities, one of the important parts about that SDG is protecting cultural heritage. So as we know, Strawberry Creek is also of cultural importance to the Huichinoloni people, who were like the first inhabitants and users of this land. So just like by protecting the ecology of the creek and like promoting awareness about that, we're aiming to protect cultural heritage as well.
Okay, so first we wanted to give an overview of Strawberry Creek in general and like the geomorphology of the area. So I wanted to also highlight specifically that the creek is a central feature of campus, and it actually heavily impacted the location of UC Berkeley and like the decision to have the campus where it is. I'll get into that in the next slide. But there's approximately like 2 miles of the creek that cut through campus, and then there's 2 branches, mainly the North and South Fork. As you can see, this is like an actual map of the creek that leads into San Francisco Bay. So it's a lot larger of a perspective, but we're mainly focusing on the portion of the creek that's included near campus. And so I also included some data collection points here. We'll get into that later on, but that's just for reference. We'll get into that in a little bit. You can go to the next slide, please. So this slide mainly highlights basically before colonization. Like Meg mentioned, the Ohlone tribe lives sustainably along Strawberry Creek, meaning that like the resources that were available and the native species that were established there prior to colonization were being like used more in a sustainable method versus after colonization. So some of the native species that we found in our research were steelhead trout, salmon, shellfish, and strawberry vines. And so basically these resources were used to sustain the Ohlone population, but obviously this wasn't the only resources that they used. And this picture specifically is not along the Strawberry Creek near campus. It's more of a reference towards like near the San Francisco Bay Area. But I just thought that I would include that just kind of as a reference for more of like indigenous practices with regards to creek management. And so essentially, when the UC Regents trustees, basically like the board that decided on where UC Berkeley campus was going to be located, they decided on the location of where the Berkeley campus is currently situated because of the creek, and it was traditionally going to be used as a main source of water, but that obviously had some problematic implications due to like the infrastructure that was developed during this period. So there was like reservoirs, dams, and water tanks, and also there was a big wastewater issue just because there wasn't like a practical sewage process that was being used. So that was leading to a lot of wastewater actually being in the creek, especially near campus. Can you go to the next slide, please? So this slide mainly highlights just previous research that's been conducted prior to our project. So essentially, there was a lot of attempts to like mitigate the effects of poor wastewater quality. And specifically, there was a sanitary sewer system established in about the 1890s. And so this was used to really help with the wastewater issue. And then eventually, researcher Robert Jordan, I apologize for butchering their name, eventually authored the Strawberry Creek Management Plan in 1987. And so this is kind of like one of the most detailed accounts of water quality in the creek, at least in like more modern day after the establishment of UC Berkeley. And basically this set a precedent for future protocol for water quality and habitat restoration. But we're going to get into some like the shortcomings of that research and where we have stepped in and tried to create more of a database for that. So we can go to the next slide.
Okay, so the chlorination of water comes with benefits of eliminating the majority of bacteria and viruses and is relatively easy to implement. However, it does come with some limitations against protecting against certain microorganisms, and research from the 1970s found some concerning potential of long-term effects of disinfection byproducts, also called DPBs. So this has led to wider adoption of chloramines in water treatment systems, which is seen as a less risky alternative to chlorine. And however, chloramine use results in new and different DPBs, and these effects are not as well understood due to the lack of attention on campus. Next slide, please. So the switch from chlorine to chloramine has done mainly with the intention of reducing harmful effects on human health, such as waterborne diseases. Chloramine is not harmful to humans in small amounts, but there are some issues associated with chloramine. So first, it can change the properties of water, causing increased corrosion of lead and copper pipes. And water management systems that use chloramine as a may see higher rates of corrosion depending on the pH of the water. Second, exposure to lead and copper through drinking water can cause health problems for humans, from stomach problems to brain damage. This is because lead is toxic and it bioaccumulates. Next slide, please. So chloramine can be toxic to bacteria and aquatic life in low concentrations, even though it's not harmful to humans in low concentrations. It is also persistent and it lasts really long in the environment, which increases downstream effects, and these impacts are not fully understood.
So we took most of our data in mid-November, and this map shows some of the sampling locations with larger dots corresponding to areas with higher chlorine concentrations. And most of the areas that we sampled had chlorine concentrations between 0 and 0.1 parts per million, as shown by the smallest dots, but there were also some areas with much higher concentrations. Yeah, so when we were initially looking into this project, we planned to kind of look into potential correlations between irrigation runoff and chlorine concentrations in the creek. But of course, a few days before we did the bulk of our sampling, the university turned off a lot of the sprinkler systems. And so we didn't collect a lot of data relating to this, but we did find that at the Wixon footbridge, chlorine concentrations were about 0.05 parts per million before the sprinklers were shut off, and there was no chlorine present later when they had been shut off. Thank you. And also, while sampling, we observed that there were areas in the South Fork that had very high chlorine concentrations at levels that were almost comparable to the chlorine levels in treated drinking water. And Ben was able to trace this back to a source a little bit north of the faculty club. And so this is an image of the source, and this is an image of sampling downstream of the input. And for context, our sampling technique involved adding this powder called DP powder into samples, and then which caused the water to change color to varying shades of pink, and then using a chlorimeter to measure the intensity of the color, which corresponded to measuring the presence of chlorine in the water. Yeah, and so our thoughts were that this input was probably associated with something relating to the College of Chemistry. And so a few key takeaways from our research are that first, the creek has chlorine in it, which is not great, as Sydney described. As Sydney described, there are some pretty severe ecological consequences associated with chlorines and chloramines in water. Also, the importance of frequent and sustained creek monitoring, and finally, the priority should be placed on reducing chlorine inputs and also potentially considering downstream solutions for reducing chlorine in the creek.
So essentially going over the progress of what we've done this past semester was starting on the left side, identifying that first there was like chlorine in the creek, because that's one thing that like the campus wasn't sure about. There were like theories that there was chlorine in the creek, but just like being able to go out and test for it and detect it, we just determined that there is like levels of total chlorine in the creek. And then after that, we were able to like map our sources and identify correlations with the like use of irrigation on campus, as well as like the correlation with that with total chlorine concentrations in the creek. And then now we're kind of at the stage where going forward, we can like based on this initial data collection, begin to generate hypotheses about like whether it's chloramine in the creek coming specifically from irrigation, or if there are other point sources, because we did see that there's a point source close to the College of Chemistry. So what could that possibly mean? And then based on these hypotheses, begin to conduct more studies And then, so those would be like future directions going forward from this project. And based on the results of those studies, we could go into like suggestions for infrastructure, sustainable infrastructure that would be low cost as well as effective to mitigate and try to prevent the amounts of chlorine and chloramine in the creek, as well as considering best management practices. For instance, maybe if there are ways to like minimize the amount of irrigation that we actually need on campus and change, like, say, the landscaping if possible. And then another step going forward would be to begin to educate the community so that folks know and recognize how things like our regular practices with sprinklers actually has ecological consequences in Strawberry Creek. And then next slide. So these are some future research questions that going forward, we hope to, like, some of us hope to pursue, or if other people who take on similar projects hope to pursue. So one would be, is the total chlorine detected in the creek free chlorine, chloramine, a mixture of both, and how long does it last in the creek, as well as how is it affecting local life cycles of the creek? So this would involve, like, pursuing that question would involve kind of updating the materials that we were able to have access to, because what we used to test for the chlorine only tested for the total amount of chlorine. So we weren't able to differentiate between chlorine, like what we use in our pools, and chloramine, which is what's used to treat drinking water. And then another question would be, how much does the irrigation actually contribute to total chlorine and or chloramine concentrations in the creek? Because, like we mentioned, there could be other more impactful point sources, like the one that we found by the faculty club and the College of Chemistry. And then another question going forward is, what low-cost sustainable forms of green infrastructure can campus implement to lower the amounts of chloramine in the creek? And this would involve some analysis of different types of infrastructure and management practices in regards to cost, maintenance requirements, durability, deployability of these different forms of infrastructure, as well as accuracy and efficacy.
All right, so currently we'll look at some of that, scratch the surface, and some potential solutions and kind of, you know, if they might work. Downstream solutions, this in particular is downstream of the input right by Stevens Hall. Filtration came up a ton. Activated carbon filters are used, you know, Brita filters are used everywhere for dechlorination. Preferably you would want a catalytic activated carbon filter, which has more of a capacity to, you know, stop chloramine and chlorine and chlorine. They are relatively expensive, catalytic ones in particular, and high maintenance, and kind of, it's not feasible for both point of use and point of entry usually. Vitamin C, as it happens, is an incredible defluorinator. You kind of see that everywhere as well. So from there, looking at low impact stormwater infrastructure, daylighting, sunlight and air, best disinfectant. It helps with the attrition of chloramine as it goes downstream. And so it's a passive, just letting it do its thing, passes the chlorination. And just minimizing inputs in general. You know, all of our infrastructure is aging currently, these pipes and intrusions, leaks, breaks with the wastewater infrastructure. It's a big problem every time. And just, you know, you don't want dumping directly into the creek that's killing everything into it. I think in 2006, the city, or just essentially right after San Francisco Public Utilities Commission instituted chlorination, there's this huge fishtail on campus. So it was like 2006. And I started reevaluating, you know, there's not really good protocols for a long time for this kind of, for chloramine in particular. Another proposal for infrastructure, curb cuts, just to like reduce the speed of runoff and prevent erosion. It's kind of the same idea as bioswales or things to keep the irrigation just moving slower so it would kind of, you know, decompose. Lastly here, investments in sensor tech, SONs, which are, we just need regular real-time monitoring of chlorine and chloramine levels in general. And that can be expensive as well, and run pretty deep. But we monitor turbidity, we monitor all these other things, but not for me. Just start looking at it. Next slide, please. And then upstream solutions. This is upstream by the fact that you might recognize that. Just general, these are kind of, some of these might sound kind of pie in the sky, but stormwater harvest would be great. We're entering a water insecure future. It's time to start thinking very differently about these things. Bioswale is what I'm kind of talked about is that zero-scaping is water conservative practices, essentially a minimal water usage. But we just really need to, look at this. Community learning and citizen science. I recently spoke to the product designer for iNaturalist and Seek, and he talks about how naming something and knowing your flora you form an attachment to it that promotes conservation. It's kind of the idea behind it. CBPR here from Belmont does this community-based participatory research. You just need to involve more people and get them aware of what's happening and understand their area. And your water, trees are our watershed in a sense, and it's all, and knowing our native plants, what's non-native, and how we can utilize that to deflor our creeks. And lastly, just kind of thinking way upstream here, let's not use chloramine, or if we can find a way to not have chloramine in our water treatment. It's a big ask, but it would avoid the entire situation altogether. And that's it. Thank you so much.
Any questions at all about our project?
Phone cover, strawberries.
Love you guys.
Yeah, any questions?
Very open-ended question, but which part of your further research are you guys more advanced in or excited about? Because you mentioned 3 different.
Yeah.
Okay. I think it's still a little bit not up in the air, but we're still kind of deciding. One thing that we're working on producing right now is a report detailing more about what we did, but also we're thinking about producing something kind of like a project proposal that would show studies, more specific studies about what we could do going forward. So I think one thing that would be a definite next step would be to just differentiate between total chlorine, or free chlorine and chloramine, so that we could better identify if the chlorine in the creek is actually coming from irrigation or if there are other sources. And then from there, you could figure out if we need to look at irrigation practices or if there are other sources that need to be addressed of chlorine.
We're a long way from, I think, reintroducing any new native species or anything. I think 1987, in the wake of that, I think in 1989 they reintroduced one fish that was it's the first time in 100 years that the creek had fish or something. So yeah, definitely recognizing also the disinfection byproducts that are what's the usual, what are the reactions happening as it goes downstream? How's it interacting with just the things along the side of the creek? A lot of questions. Thank you.
Yeah. You guys talked about maybe you said big apps, but replacing chlorine. I'm assuming you'd have to use some other compound or elements for that. Do you have any ideas of what that could be?
Oh, well, there's so many. There's a lot of sodium sulfides, various sodium. There's so many compounds that are used for it. They're all pretty synthetic. Chlorine's an extremely electronegative. I don't understand the problem there. I don't have any answers for that one. Yeah, if anybody has any ideas.
Chemistry knowledge.
And this last question, when you're talking about differentiating between chlorine and the chloramine, is that something you're still looking at the technology for, or do you guys know what to use or do differently next semester?
Yeah. Okay. Yeah, so it's no, I think it was more so us having access to it. I think the only difference is a different type of powder that we would dump into our little vials when testing. So it's just that we weren't able to get those this semester, but being able to have that and then solidify if it's chloramine. Basically, what that would look like if we were like doing that going forward would be to test for total chlorine, and then also have another packet to test in that same sample for the amount of free chlorine, because that's the other like powder packet that's available. And then subtracting the difference would tell you how much chloramine is, if that makes sense. How much chloramine is in the sample. Yeah.
I think the device we use measures in CL2. So, and the chloramine picture, then there was a monochloramine, it's found most common, NH2Cl, and the DNH is a little faster. But you see other like trichloramine, there's other chlorines out there. But yeah, it'd be interesting to see what else chlorine is bonding to. And, yeah.
Next we have consumer culture and climate change.
Hi, everyone. Thanks for joining us today. We're going to be talking about our project from this semester. We analyze the impacts of consumer culture, overconsumption, and consumer behavior on climate change. Next slide, please. So my name is Kayla, and I'm here with my teammates.
I'm Lou. I'm Priya.
I'm Erin.
I'm Mary.
I'm Julie.
I'm Anjika. I'm Ankita. And next slide, please. And so I'm going to talk a little bit about an overview of our project. So we'll talk about a little bit about the goals of our project. We'll talk about the definition of overconsumption in the context of our project. We'll talk about the history of consumer culture and elaborate a little bit more about current solutions to climate change and analyzing those in the lens of overconsumption. And then next steps we'll take for next semester. Slide, please. So a little bit about our project. So here are some foundational questions that we looked into. So our project is divided, is a year-long project, and for the first half of the semester, we looked more into the historical context of consumer culture and looking into existing solutions to climate change and looking at it at an overconsumption lens. So some questions we looked into is, for example, what are the historic and current factors that drive consumer culture, specifically overconsumption, the root causes of overconsumption, and what are the local and global environmental impacts, and some existing and solutions and initiatives to climate change that are in the conversation. So who is proposing them and what are the motives of these solutions? On that slide, please. Yeah, so to expand on those foundational questions, this project was really born out of an observation that there's an increasing global mobilization for climate action. And so we wanted to take this part of our project as a checkpoint to really assess these climate solutions that are being proposed by different entities. So this semester we focused on questioning the impact and the credibility of these climate solutions through the overlooked lens of overconsumption. And overconsumption is not often talked about because it's such a complicated topic. So that's why we wanted to focus on it. And a little bit more about our framework this semester. We started off by doing some more research into overconsumption, what the existing language is. And then we went into climate action and solely focused on what different entities are talking about when it comes to climate action, because we recognize that in society, different people have different interests, and that affects their climate solution. So that's how we categorized our database kind of climate solutions. And then we concluded this semester with overlapping the two. So we essentially critically looked at these climate solutions through the lens of overconsumption. And we asked, is it promoting overconsumption? How is it interacting with that topic? Yeah, and I'll pass it on to Erin. Next slide, please. So we focus on 3 goals for our research, SDG 9, 12, and 13. So SDG 9 hopes to build resilient infrastructure, promote inclusive and sustainable industrialization, and foster innovation. And this is key as investment into research and development is really important for helping countries recover from economic crises. And the second one is SDG 12, which basically ensures sustainable consumption and production patterns. This is really important because even now, the environment is quickly deteriorating due to our unsustainable use of natural resources and our growing global population. And our last goal is SDG 13, which urges people to take urgent action to combat climate change and its impact. And it hopes to create a better world where we don't have to rely on carbon emissions and we can separate economic growth and climate catastrophe.
So now we will be talking about our definition of overconsumption that we have found through the course of our research. Next slide, please. So overconsumption spans from a local to a global scale, but in the context of our research, we understand it as a phenomenon rising from our current global systems, where more resources are extracted than can be sustainably replenished, where more is produced than used, and specifically where these resources are being consumed by a small amount of people, resulting in inequities and uneven distribution of the negative externalities of overconsumption. Now I'll pass it on to you.
Next slide, please. Okay, so yeah, next slide again. So here just a few information about the beginning of consumer culture and overconsumption. Basically, we have always consumed for survival, and for the 18th century, there was no economic motive for increased consumption. But then in Britain, there was some attempts to boost sales, and it extended to the entire population over time, with retailing passing from small shopkeepers to corporate giants. And yeah, basically profit seeking took over usefulness. So we identified the main causes behind overconsumption. One of them is materialism, and some researchers have shown that the consumer purchase can be a means of achieving happiness and alleviating insecurity or anxiety. And then we have supply chain management, especially in the 1950s, with new production techniques allowing to produce at larger amounts to meet the demand, but it will increase consumption, obviously. And then grid marketing has also an important impact, because even if goods are becoming more eco-friendly, it still increases the consumption, and we keep extracting resources at a level that is not sustainable.
So we also identified a couple of current drivers for overconsumption. The first one was economic growth and technological affluence. So when economic growth and consumer demand became unsustainable during the Industrial Revolution, yeah, I'm gonna block it. Yeah. Sustainable development was only just beginning. So today we kind of see this persistent pattern as GDP per capita and population growth increases. And then next we have waste distancing. So this is when consumers often treat waste with like an out of sight, out of mind perspective, and they aren't able to deal with the consequences of excess waste directly. And the last driver was mass media, so driving overconsumption through advertisements from corporations and companies, just pushing consumers to buy more and more, obviously leading to excess waste. Next slide, please. So overconsumption in the context of climate change. So we saw that most of the causes and drivers that we emphasized are consequences of capitalism, which has a goal of continual profit seeking. So industries are emitting more and more carbon, burning fossil fuels, and overusing resources as a result of increasing consumer demand. And I'll pass it on to Priya.
Next sentence, thank you. So now we will be talking about the current solutions to climate change by different entities. So to start off, we have private organizations. We looked at mainly large companies and their current solutions that they have to climate change. So as you can see here, we have Shell, Costco, and Apple, which are just 3 of the companies that we looked at out of the many. And we found that these companies shared similar solutions, so we put them into themes. So the first one we have is sustainable sourcing. For example, Costco will be strategically sourcing their merchandise in a sustainable manner. We have carbon emissions, where, for example, Apple is pledging to be 100% carbon neutral in products and supply chain management by 2030. And then for external organizations and certifications, we have, for example, Shell, which is trying to support the UN Sustainable Development Goals. Anjika will be describing more of these solutions in detail.
Yes, so to elaborate, we found 3 main methods that companies have been using all across the board to address specific climate issues. So first, to address the issue of so many of the products are made from plastics and the plastic packaging. So this usually ends up directly into landfills or aquatic regions. So a solution that companies are using for this is to create products from plant-based materials, which makes it compostable, or they are increasing the amount of recyclable materials that the product is made from. And another issue is that many of the environmental and social impacts of big business practices is coming into light. It's getting more attention. And to address this, companies are partnering up with external certification companies to prove or to measure how ethical their practices are, especially in relation to others. Yeah, next slide, please. So a third big one is that fossil fuels fuel businesses on every level, from transportation of the goods to producing the plastic used in the product or its packaging. And so to combat this or to address this, companies are investing money in decarbonizing technology, and they are purchasing carbon offsets, which will essentially reduce their own carbon footprint. Now I'll pass it on to Julie.
So next slide, please. Within the category of public organizations, we chose to analyze urban planning as a solution to overconsumption, and we found it to be highly effective in the tackling of transport consumption as well as unifying efforts. But also additionally, we found some trends that in cities' climate action plans that have a growing tendency to mention equity as part of their objectives as well. And so that includes a wider definition of sustainability that includes both the dimensions of both the economic, social, and environmental dimensions, and enables city officials to have more specific goals to then tackle. Next slide, please. An additional solution that we examined and that Anjika mentioned was the certification entities mechanism. And we found some shared values along with urban planning. Just like we mentioned, sustainability action plans have kind of redefined our approach to climate action by including this new aspect of equity and inclusivity. And so that translates into a reinsertion of marginalized communities within cities, as well as an inclusion of consumers within more symmetrical and more inclusive market dynamics with a better knowledge of their products. But along with that, there are also a string of shared issues, such as accountability, measurement issues, and the issue of scope that we'll mention later on. And next slide, please. So now I'll pass it on to our last member, Danny, with this recording on movements and their current solutions.
So yeah, another entity we looked into is international organization. Are you good? Okay, cool. So another entity we looked into is international organizations. So two solutions we looked into is the UN and the World Bank. The UN is known for mobilizing countries all around the world together to tackle climate change in 3 different ways. So one way is creating environmental treaties such as the Paris Agreement and tackling carbon emissions and climate agreements, and then creating SDGs, which we are looking into as today, and then creating like climate conferences around the world to tackle climate change. And another solution we looked into is the World Bank, and they're known for helping developing countries in financing their efforts to reduce their environmental impact. Next slide, please. And some overlapping trends between these two solutions is that they both mobilize countries around the world to tackle climate change, but there are some flaws to both of them. There aren't really strict frameworks for holding these countries accountable if they are not really fulfilling their commitments, and they do have very complex systems that are intertwined with political and financial interests that Ankita will elaborate more. Next slide, please. So now we'll look at solutions that are, now we'll look at these solutions in the context of overconsumption. Next slide, please.
Yeah, so when we look at these solutions through an overconsumption lens, it becomes clear that the ones by the private organizations are encouraging false sustainability. So first, with compostable materials and recyclable materials, these are very complex processes. And so, for example, compostable plastic needs to be industrially composted. And second of all, recycling is a complex process, and the success of it depends heavily on the location of the person, because cities and countries handle recycling differently. And it depends on the amount of mixed materials that the product was made from. So overall, consumers believe that they can consume the same amount of plastic and single-use packaging, but do not have to pay an environmental price anymore. Next slide, please. So with decarbonizing technologies and investing and lowering company emissions, from a company standpoint, they simply need to reallocate their finances in order to claim they are implementing climate solutions. So for example, carbon neutral and carbon offset, this assumes we have a give and take relationship with the earth that results in like a mathematical concept of zero. We can equate, like get rid of how much damage we make, but earth is a multi-layered system and it's been out of balance for a long time. So the belief that the climate crisis is being properly dealt with by companies fuels overconsumption. Next slide, please. And lastly, with external certifications, companies have begun to heavily rely on this as their method of addressing climate change, rather than creating more systemic changes. And there is still a layer of transparency missing on the consumer side. They don't really have access to what companies specifically do and what changes they make to be eligible for the certification, or even what it means to be eligible for the certification. So it's kind of perpetuating these band-aid solutions. Next slide, please. So despite all the knowledge we have on climate change, and despite all the knowledge we have, millions of dollars and advertising are being poured into the solutions we just talked about. But the big takeaway from this is that the world, predominantly the global north, is still consuming and producing the same amount of packaged items, which leads to overconsumption. Now I'll pass it on to Julie.
So as we mentioned previously, both urban planning and certification entities that we categorize as private, but certification entities can be both public and private, so we've chosen to mention it here as well. So both of them constitute very high profile solutions to overconsumption and consumerism through the mechanisms of direct policy mandating and implementation, as well as incentives and market differentiation of products and brands. But there are also some limitations and challenges that are really worth mentioning, especially in terms of urban planning. Cities publish action plans, but they also have to be integrated within a regional network and assessed by tools that are able and reliable enough to measure multi-level data and multidimensional as well. There is also an issue of liability in case of failure to perform and to meet these sustainable goals. And on the other hand, in the case of certification entities, they also have a frail scope of action as they heavily rely on incentive and are based on a voluntary basis. So they are especially frail in comparison to other mechanisms that enable business regulation and their activity, business regulation, such as, for example, carbon taxing. So I'll pass it on to Ankita to explain more about international organizations.
So focusing back on these organizations, when you look at them through an overconsumption scale, you start to see that there's a lot of discrepancies when it comes to climate action. For example, the World Bank, they fund renewable energies, but they also fund fossil fuel projects. And so the issue that rises with these organizations when you address it from an overconsumption lens is that they're very large organizations, and while they're highly influential, there's very large issues of credibility and accountability. And they're both top-down systems that thrive off of overconsumption, especially because both of these organizations and a lot of organizations like these establish the first world and high GDP as the standard. So when they're addressing other issues and development issues, what they're looking towards is a first world consumption rate. And that's how these issues, these organizations still end up fueling overconsumption. And I'll pass it on to Erin.
Next slide, please. So we focus on three main movements for our solutions. And the first one is minimalism, which promotes conscious consumption and helps reduce the demand for natural resources, which are becoming more and more limited. And this ultimately helps limit overconsumption. And the second one is circular economy, which tackles the entire supply chain and tries to bend the industry back into harmony with nature. And this hopefully can reduce production and the consumption of resources and gives them another purpose rather than simply throwing them away. And next slide, please. And the last one is the green building movement, which hopes to keep buildings accountable for their waste and ultimately helps prioritize sustainable construction and production of buildings rather than materialistic and wealth gains. And I'll pass it to
Okay, so we'll move on to our next step. So some takeaways from this semester after looking at multiple entities, it's really that overconsumption needs to be at the forefront of the climate change discussion. Because if it isn't, we found that climate solutions are often narrow and fail to address inequality, materialism, global societal structures, and heavy resource extraction. And overconsumption clearly from this, after all this research, can no longer be an issue too sensitive or too complicated to tackle. And that's what we hope to do. We hope to provide alternatives next semester at what these organizations can do when they think about overconsumption, as well as climate action. And Kayla will pass on just to go over the end.
Yeah, so as I said in the beginning, this is a year-long project, and the last half of the semester, which is next semester, we are going to be focusing on looking into like these solutions that we looked at this semester, and then finding gaps and seeing how we can fill those gaps. And following up with Rankita said, we're going to look at these solutions more critically and in overconsumption lens, and also thinking about it in the systems framework, seeing like what stakeholders are impacted and how are these solutions not only impacting the environment, but the people who are impacted as well. Next slide, please. And so thank you for listening to us. Our report will be on the website if you want to learn more.
So if anyone has questions, we'd love to answer them. If we have time.
I have one of them. I was gonna ask, like, have y'all looked at like anti-capitalism structures, and how that could impact overconsumption or like
That's something I think we'll address in our goal 4, which is looking at alternatives. And so we really wanted to get to like anti-capitalism, anything outside of current like functioning society as alternatives. So that's definitely something we'll be looking at.
Did you guys analyze the option that companies like before, after, or even Shell has done?
What do you mean by analyze?
Greenwashing?
Oh,
Yeah, I don't
yeah,
know. Just
clear.
So we looked at what they presented for sustainable solutions on their like main page. And we didn't really go into it in this presentation due to time, but we did definitely feel that a lot of them were doing greenwashing because there's not much enforcing going on. And so they can say their goals, and a lot of their goals are more like very in the beginning. So it's more like, oh, we will have a goal about what we're going to do by 2030, rather than here are the steps and here's the action that we've already done. So we found that they were detailed in what they've done already, but in their future goals, very vague. So we like on our own, we're kind of like, you know, not too happy with a lot of the goals that we have been seeing.
Can you define what greenwashing is?
Yeah, so greenwashing is when a company will say that they are, you know, trying for sustainability, that they're doing these environmental things, but then it's not really legit. It's not really real.
Yeah, this is also part of our goal 4, where we're going to take these solutions that we mentioned here and more critically like analyze them and with a more rigorous lens. So that's definitely something that we kind of slid over here. Like we said, like compostable materials and external certifications, like these all have their own caveats. So we're going to go more into that and go more.
Yeah, my question is kind of similar. Just like if you looked into any large companies and like there is something for that. Like for example, Apple has like the return that I find actually be more circular. So if you analyze any companies that, for example, maybe that's something. Sure.
Here, did you want to answer that more?
Yeah, so I mean, for now, we basically like compiled what the solutions that the companies are doing, but in terms of actual like analyzing, you know, every step of the way, that's more of a goal 4 type thing. But yeah, we did find that Apple had that recycling program. They are doing some things that are really good, and other things are more for the future.
Yeah.
I was just curious, for the external certification programs, are those like, or those companies, is it like a one stamp kind of like thing, or is it like every year, like companies get renewed, or how do they work?
No. Yeah, so we looked into like B Corp, and they're like a common certification company, and companies have to renew it every year. And it's actually like an online assessment. So every year, I think they have to like submit like the amount of emissions they emitted every year. So yeah.
Yeah, with external certifications, they're on their own, like it's really good because they're trying to bridge like information gap. They're trying to make business practices more transparent. the way that businesses have reacted to them and are now like relying on them as a way to deal with climate change is becoming a problem. And it's become like their main method versus a more systemic change they can make.
I think that's all we have time for, but we have a website and also you can talk to us after.
So the next phase of our presentations is something new to SURG. It's something we worked with the Carbon Neutrality Initiative, which is an initiative to try to get the UC system to carbon neutrality by 2020, by 2030, 2025, carbon neutrality by 2025. And it heavily relies on the use of carbon offsets, as many of the campuses still use fossil fuel generation. So the UC system is doing a really unique thing where they're investing in their own research. And so a lot of our researchers got to take a chance and look at some of the research and they're going to present on it. Cool. Unite to Light group come first.
So hi everyone, we're the Unite to Light or Projects Unite to Light. My name is Lucius.
And I'm Pooja, and Danielle is our third member, but she couldn't make it.
So these are just our kind of framework for our presentation today. I'm just gonna explain briefly what is Unite to Light. So Unite to Light is a project that distributes solar lanterns in rural Africa, and then it replaces kerosene lanterns. The project is a partnership between the Unite to Light and another nonprofit organization, Solar Sisters, and they work with, Unite to Light works with the University of California to do carbon offsetting. So this is kind of the main replacements of kerosene. So right now, currently a lot of energy lighting from especially in rural Africa, they use kerosene, and that's very damaging to both the environment. It's also pretty bad for public health. So this is kind of the solution or alternative that Unite to Light is and Solar Sisters are distributing to communities across rural Africa. So basically, there's just this kind of photovoltaic like cells that just take solar, and then it generates lighting on the top there. And this is like really useful for like students when they come back to home to study, instead of using candles or other harmful alternatives, which is like kerosene, as mentioned before. So this project was selected as one of the first 12 pilot projects through the UC Carbon Offset Program with the following goals, and I'll outline kind of the goals. So there's like a lot here. Obviously, first, it helps improve public health. Kerosene is very environmentally damaging, but it also has an adverse effect into health. A lot of the housing, the kerosene emissions would just get into the house, and it's just very stagnant. So it has adverse effects. Obviously, it helps with carbon offsetting, but then it also helps with increase in electrification. A lot of the electrical grid in rural Africa are in particular not very strong, so they use like candles instead. So the Unite to Light project is kind of to use these portable kind of lighting systems, as you saw before, the loop lights, to bring electrification rates up in rural Africa. And then it also helps with economic opportunities. How the program is kind of set up is that Solar Sisters, which is the nonprofit Unite to Light works with, they will distribute those loop lights as seen in the earlier slide, and they will bring that to women, And they are particularly selected because they have a expertise in the communities they are living in, and they kind of distribute that to households from there. So they specifically want to work with women and also bring the economic benefits to bring like kind of the gender balance as well. So the first part of the phase, which we were working on this semester, they worked on it last semester. So they worked in Tanzania. They did like a project like test run. They distributed 2,000 loop lights to Tanzania. And now, because of the success of the project, they're expanding it to both Kenya and Nigeria. And they're distributing way more. So the initial test run was about 2,000 lights. Now they're expanding to 15,000 to 20,000 per country. So not only are they expanding in Tanzania, but they're also expanding to other countries like Kenya and Nigeria. So 20,000 each for 60,000.
And then going into kind of how our meetings and how our work was structured. So we would have a weekly check-in every week where we would just basically meet with our the project lead and discuss any clarifications or questions we had about our work. Next slide. And then during the week, we would do some research into a couple of things that were important when calculating baseline kerosene usage, such as poverty rates, energy use, and waste disposal. And then a couple of key findings that we found through our research. The first was that rural kerosene usage was greater than urban usage, which kind of points to one of the reasons why Solar Sister is specifically working in rural communities. The second key finding was that kerosene is the main source of lighting in the countries that we were studying, Nigeria and Kenya, which again is a problem, as Lucius mentioned. Kerosene is harmful for not only public health, but also for the environment. Another key finding was that there are low electrification rates. Electrification rates basically just calculate the amount of people who have access to stable energy. In Kenya, that's 69% overall, and in Nigeria, that's 55%. And another key finding was also that the poverty levels in these countries are high. Again, we looked at a couple of indicators. One indicator that we looked at was the multidimensional poverty index, MPI. This basically takes into consideration health, education, and living standards. And then we also looked at the international poverty levels, which is basically the percentage of people in the country living on less than $1.90 a day. And so that's 37% in Kenya and 39% in Nigeria. And then some challenges that we faced throughout the process. The first challenge that we faced was basically ensuring consistency across data sources, because some countries would have their national government produce a report on like their poverty levels, whereas some countries wouldn't. So ensuring that we had consistency across data sources was really important to our research. Another thing along these lines was we were trying to get the most recent information, but some surveys such as the international poverty levels are only calculated every 5 years. So this was an issue when we had some data sources from 2016, whereas some data sources were from 2019. And then in terms of our current progress, so currently we're working on transferring all of our research into the project document. And this document is going to be submitted to the University of California. It basically calculates like baseline kerosene usage and the offsets from this project. And so yeah, that's our project, and we're open to any questions.
It's kind of basic one. Just kind of Solar Sister, is that like Sister City initiative, or is that why Solar Sister?
Oh, it's because they're working with women specifically, as mentioned before. Yeah, they're basically, the model of how the system works or the project works is that the United Light calculates like what is needed, like the amount of like lights that are needed, using a lot of the data we collected. And then Solar Sister is the other nonprofit, and they mostly work with like distributing and giving like expertise to like teaching women how to like kind of talk to their communities and how convince to use those loop lights instead of kerosene and kind of teach them their communities like the public health adverse effects of using kerosene. So I guess to answer your question, they mostly work in rural environments too, because the electrification rate is much lower compared to urban areas. So yeah.
I was curious if there's any belongs to these sites, these homes, or are they found elsewhere, different appliances, things like that? And if there's like a more widely available substitute there that can help with those things.
Yeah, so one thing that we didn't look into for our project was kerosene emissions from cooking or like stovetop, because we were only focusing on lighting since we're like distributing the light. But yeah, in terms of cooking, kerosene emissions is also a huge issue because again, when women are cooking, like when women predominantly are cooking meals, then the kerosene emissions are really harmful for their health. So to answer your question, yes, there would be like kerosene emissions.
It's still a quick question. Do you know how the three countries were chosen to
I think they were chosen, well, Tanzania, I'm not sure why the Tanzania was chosen, but I think for Kenya and Nigeria, they were chosen because the information we gathered, like look at it holistically, the poverty rates, the electrification rates. Again, we mostly focus on rural localities. So that was also another factor is we really dig into the data to see like, which countries their rural electrification rates are much lower. So our project lead kind of just took all the information that we gathered and then they kind of chose the countries from there.
Cool. Great job, guys. Get our Seaweed project.
Hello, I'm John.
Yeah.
And we research production of real seaweed to mitigate methane emissions in California livestock.
So we're part of the Carbon Neutrality Initiative program here. So it's basically been declared in 2013 that the UC system wants to be carbon neutral by 2025. So the part of the program that we're working with is kind of like the potential offset program. So there were 12 projects chosen for these pilot awards basically, and they're tasked with bringing their projects kind of to like full realization to like see which ones like really work for UC offsets. So specifically, we're more focused in the California projects because we're related to like red seaweed and like methane emissions related to the livestock that the UC has in California and kind of reducing emissions in that sense. So the red seaweed program is working with research teams at UC San Diego and UC Davis. So basically they're working with Asparagopsis taxiformis, which is a type of red seaweed. So they're using it to supplement livestock kind of feed. Basically, they're putting some of it into the feed of livestock, which can reduce methane emissions by 30 to 90%. And these like methane emissions result in like a greenhouse gas of like 4% just from this livestock alone. So basically they're trying to use Asparagopsis taxiformis, getting it to reach like a level of cultivation within the UC system that's like cultivated like indoors, which really hasn't been done yet. So that's kind of the whole point of this project, is getting the cultivation of Asparagopsis in an environment where it can be most efficiently made and then introduced into the feed of livestock so that it can help to reduce those methane emissions by a very significant amount of 30 to 90%.
So our part in this project, huge thanks to Patrick Cage, who's the project manager and also our mentor. And our goal was to get an estimate of the net greenhouse gas benefits and analysis of the economics of Asparagopsis as a feed supplement and determine the viability of the project. So in simple terms, we're trying to parameterize carbon emissions. So let's say we have an X amount of carbon that we have to offset. Okay, how much seaweed are we gonna have to grow for that? What are the variables that we're gonna have to analyze? And once they all come together, we're gonna build an economic model to help us determine whether this will be a viable method or not.
So this is pretty much what I was focusing on. So first I started researching emissions factors dealing with fertilizer. So we looked at the fertilizer used currently in the system and the different amounts used and the amount of pretty much asparagus yield that it would provide. And then we looked more into the chemical makeup of the fertilizer, the chemicals used, the greenhouse gas emissions of those chemicals, as well as the aquaculture process in general and the types of fertilizers used, which was more, strangely enough, related towards like fish meal and stuff like that, which was unexpected. And then kind of just looking at the costs of those different combinations of fertilizers, because it was pretty much like a component of fertilizer made of 3 different subtypes and levels of fertilizer that could be used. So it's pretty much looking through all these different subtypes, finding optimal yields and mapping it all out in a sense that it can be coded, which is our scaling data sheets that were used at the end of like kind of our data, just making it so it can easily be put into a system to pretty much maximize the efficiency of this whole thing pretty easily. The second thing that I looked at was the parts typology. So basically it was looking through a written typology that was given to us by Patrick and just matching all these different parts and small pieces of like this pretty intense program with like pumps, hoses, filters, a lot of different filters, bag filters, cartridge filters, sand filters, matching it all to a diagram and then putting it into a Slab Lab spreadsheet that basically had notes, costs, URLs for access to both the like specific one used in the project currently and alternatives that could be more cost effective. And then looking at the amount used in the process as well and just making it all very easily readable to us ourselves, as well as later on, hopefully a code. And then the last thing that I worked on was the lyophilization process, which is freeze drying. So basically this seaweed will be freeze dried at the end of the process. So it's looking into what the freeze drying process is and kind of learning about that in general. And then just kind of looking at the costs of commercial freeze drying and home freeze drying, the amount of electricity used, and a lot of different like space things within a freeze dryer as well, looking for the amount of efficiency that could be used from each freeze dryer, and then kind of putting that also into a scaling data sheet that can then be used to be read by code in order to make basically the most effective and efficient process of the most efficient processes for each little piece.
I did pretty much the same thing Bia did, but for pumps. So there's no need to go into details about what I did as well, but when it comes to pumps, there are other variables such as efficiency, specific gravity, the flow rates, or the head, which pretty much means where we're getting the water from, like the height to where we're getting the water to. And imagine a class that has all of these subclasses, which are our parts. So there's a fertilizer one, there's a pump one, there are other ones, and all of these are going to be read to find the most efficient way to grow the seaweed to offset carbon. So that's what our project is going to look like when it comes to that. And thank you. Do you have any questions?
So just want to clarify that like the research that you guys did was like focusing on like the process of making the red seaweed, right?
Yeah, so they're kind of working in the lab itself, they're culturing the red seaweed there. We're working on like a greenhouse gas emissions kind of overview that's in the end going to create like the most efficient process for this culturing method so that they can pretty much make this seaweed itself for the offsets with as little carbon emissions as possible. Yeah.
So a lot of this about using red seaweed for feed replacement. Does that work for like all kinds of livestock, or is it more specifically targeted for like cattle? Or what's the?
So I think it was more specifically targeted to cattle because it's the methane emissions that I know that it reduces. I'm not sure if it has like other reduction effects as well, but I know that it does like pretty significantly reduced methane emissions, which I actually learned that the like UC system has like cattle livestock itself. So that is like really good for us.
Thank you, guys.
Hi everyone, my name is Alvin,
I'm Misha.
and today we're bringing to another UC carbon neutrality initiative, which is called Adopt Cookstove. So in brief, when we look at the project itself, it kind of began with this idea that back in based in UC Santa Barbara, when the environmental department program and some of the researchers there trying to develop this fuel efficient wood pellet gasifier stove to go in and serve in the fields in rural Rwanda back in 2018 until now, to see how that could improve the health conditions and also at the same time offset carbon emissions. And what we've been doing is we've been working on mostly literature reviews and also while they are collecting data. So,
Some of the main project methodologies that we focused on is like life cycle assessments of different types of cook stoves. And essentially a life cycle assessment is calculating the emissions that a cook stove produces from like its production to like the end of its life and like, kind of degrading it. So we compare like different types of fuel and stoves. So kind of the main traditional stove that most of the communities in Rwanda use is like the firewood stove, like a 3-stone fire stove. Then kind of like the next level of stove is the charcoal one, and then the ones we distribute is the wood pellet gasifiers. And these stoves kind of emit different types of greenhouse gas emissions, black carbon and organic carbon. And one of the main differences that the Adopt a Cookstove project uses is that when we calculate these emission factors, we take into account black carbon and organic carbon, which is not necessarily done. And black carbon is like particulate matter. You can see it in like soot, and like it's particulate matter is extremely harmful to like respiratory health. And then organic carbon just comes from nature. And then yeah, there's different like scenarios that we use, like business scenarios and like biomass management to calculate like these different things. Next slide.
So this is just a very brief connection to some of the sustainable development goals that we have. And of course, since this is a year-long project, as we continue to develop what our engagement research and data collection, we may potentially realize there's more connections, more SDGs to be connected.
So the main things that we're going to be talking about today is trying to get this project to generate carbon credits, the differences between uncontrolled and controlled emission reductions, and then societal impacts as well. Next slide. So here we'll be talking about carbon credits and trying to generate carbon credits through this project. So carbon credits are like tradable permits. One carbon credit equals like 1 ton of carbon dioxide emissions, and corporations kind of like want to trade these credits with these carbon offsets projects to help them reduce their own like greenhouse gas emissions. And so one of the main reasons we want this initiative to generate carbon offsets is because carbon credits can kind of help us like reduce like the amount that we have to pay for the project ourselves. So there's like 2 different methods of counting carbon. One of them is the clean development method, which is generated by the United Nations. And then we have the gold standard method, which is kind of like a third-party carbon offset scheme. And the clean development method, when you generate carbon credits, you can generate like certified carbon emission reduction credits. From the gold standard method, you can generate voluntary emission reduction credits, kind of just 2 different markets for them. The main difference is that the gold standard one is like a third party, while the certified one is through the United Nations.
Okay, so while we do see that this SURG methodology for carbon credits is working and it's more or less standardized internationally, as we look at some literature, we do see that example in Kenya, where rural women as they're using these hot energy efficient cook stoves, and they're also at the same time they're financed by these what they quote unquote these volunteer effort, voluntary offset markets. What's happening is that some scholars argue that these women, they're more or less being exploited and being what they call like these virtual commodities, and they take it for granted. So what happens is that these women, these rural women, they sometimes they just cannot have, when they're being given these cook stoves, they just cannot quickly adapt to that. So they'll more or less use the traditional ways of those traditional cook stoves. So that implies that these cooks, the emissions of cook stoves will still be substantially high. It's not going to be like, oh, when you get these cook stoves, all the emissions drop substantially. So there's that cultural, social reason behind it.
So this graph here kind of just shows the difficulties that Cookstove's project have when it comes to generating carbon credits. So the blue diamond here shows like the clean development method carbon credits. The red dot shows ones generated through the gold standard. And you can see that the clean development method, like none of these cookstoves generate carbon credits through that. Only 2 cookstoves generate carbon credits through the gold standard method. And it's the last 2 over on the right. It's going to be the kerosene stove and the liquid petroleum gas stove. And one thing to keep in mind when generating carbon credits is that it kind of depends on the project. If communities traditionally use like a traditional 3-stone fire stove and you replace that with like a kerosene stove, the carbon credits are calculated based on like the displacement of the emissions that they produce. So even though kerosene is not necessarily beneficial, it can still produce these carbon credits through the gold standard method.
So next we look at another aspect of this whole thing with uncontrolled and emission reductions, so with sort of like different conditions of where these cook stoves are placed. So in simple terms, we see that it's controlled and uncontrolled, where these from here we can, so some cook stoves are being placed in laboratories, whereas some cook stoves are being put in field, they're being being put on spot where rural women are, and peasants there are trying, they're using that hand in hand. So another one of the cases is that at least that what I found is that there's the scholars compared 4 countries and they looked at these efficient cook stoves versus these traditional cook stoves, and what using this sort of organic carbon elemental carbon ratio model to monitor the PM 2.5 levels, because as Aisha just said, some of the carbons that the carbons that are being measured, it's based on, can be measured based on PM 2.5 levels. So what we will see on the next slide is that we see that Honduras and India, they have a slightly lower emissions than others, because what we're trying to essentially do at this point when it comes to literature reviews is to realize that these fuel efficient cook stoves are truly efficient than these traditional cook stoves. But then given there's many different confounding factors that influence that. So with the next slide, you can see that just a really like comparing these cooks, like improved cook stoves to traditional cook stoves, like the PM 2.5 emissions represent all by these dots. And we see that there is a big contrast between what we call on the y-axis, that is the efficient emission factor over here. But then what's more significant here is that, like from the research that from the previous case study that I just shown, the compare like for example Honduras to India, it shows that Honduras, based on this whisper plot here, it has a more steps like slightly these like improved results have like slightly lower emissions, and comparing this to many other countries, because like say for example like China, they put a lot of cook stoves across the country, so it's hard for them to kind of see that that sort of slight decrease in the carbon emissions because of many different regions. Like say for India, they have very different conditions, whereas like Honduras, like more small country, they kind of experience more or less similar climate.
So we also want to talk about the societal impacts here. And one of the main things that we want this project to do is kind of increase awareness of public health. And so using like normal cook stoves, like traditional cook stoves, they are really like detrimental to respiratory health. There's like indoor air pollution. And one way that we can calculate if these new cook stoves that we implement, the wood pellet gasifiers, are like beneficial to like improving health is like kind of comparing our data to like food targets for air pollutants. And so we use like these two targets for carbon dioxide and particulate matter to kind of quantify if we kind of meet these goals. And then another impact on society is that by using wood pellets instead of like collecting firewood, there's more time for people to engage in other activities like family activities and educational opportunities. And so this slide here, it kind of just shows how difficult it is for cook stoves to reach these two targets. The tier 1 stoves are like traditional stoves. 2 and 3 show like interim progress and like improving efficiency. And then tier 4 is like aspirational. This is what we want cook stoves to be like. And you can see tier 4 stoves are the only ones that reach these food targets. So like none of the stoves that we have in these countries now are reaching like food targets for carbon dioxide emissions or for particulate matter.
So we have so it's kind of references that we have, and then future state goals go look at that. So I think that's what I'm doing. And if there's any questions, please feel free to like shout it out.
Oh, thank you guys. Great job.
Woo!
We have one more group. I know we're a little bit over time, but we really appreciate it. You guys stay on.
So our next project is actually not a part of CNI. It's part of this other initiative called the Peter Sather Center. And basically they fund grants and fellowships to various professors and GSIs, graduate students who request specific research projects. And it's actually UC Berkeley is in collaboration with a bunch of other Norwegian and European institutions. It's a really exciting initiative. Let Sonia take it away with her project.
Hi everyone. So I'm Sonia Rodrigo. I'm an exchange student from Spain. So I'm as associate, I participated in this project, which is part of the Federation Grant Program. And it's a collaboration between the University of Berkeley in Norway and the University of California, Berkeley. And these are the team members. Alistair and Alicia are the principal investigators, and there are also Robin, Nina, and Inger who are also participating. Well, the project is still in an initial phase, so I'm just going to do an overview of the research questions and what I've been working on. This project focuses on the problem of generational renewal in Europe and in North America, specifically in Spain and in California because of their similarities. And it's a very important problem because of the lack of young farmers, and this translates into challenges regarding sustainability and dynamism in the sector. The first part of the project focuses on the policy environment in the European Union and in the US, and how different policies affect this problem and how there are still gaps and barriers to young and socially disadvantaged farmers that cannot enter the sector. And then the second part focuses on youth farmer movements and organizations and how they perceive the gaps and the barriers and how they can also have a role in generational renewal and sustainability. So as I just said, there are like two different parts of the project. The first one, so the first research question focuses on the policy environment, and the second one young farmers and their visions and experiences regarding sustainability. And I've been working on the European Union side of the project. So just so you can get an idea of the importance of this problem in the European Union. In 2016, for every young farm manager, a young farm manager is whoever has less than 40 years old. So for every farm manager under 40, there were 3 farm managers over 65. And I've been working on collecting information on the policy part of the project in the European Union. The main policy instrument is the Common Agricultural Policy, which is based on 2 pillars. The first one is based on income support, and the other one is focuses on rural development in a broader sense. But this policy fails to address the high barriers to young and socially disadvantaged farmers. The main one is access to land because of unavailability prices, and also because older farmers do not want to pass on their lands to younger generations because they get benefits from land ownership. And there are also other challenges such as knowledge needs or access to credit. And then I've also been collecting information on youth farmer organizations and how they can contribute to proposing solutions to the generational renewal problem. And even though there are some organizations that do not care about sustainability, most of them do, and some examples are these initiatives. For example, Red Terre has organized an initiative to connect young farmers with older farmers so that they can get land more easily. And this is everything we have worked on so far. Do you have any questions?
Are you just looking at like age demographics, or also looking at like race or social economic or other factors?
Yeah, we are focusing on age, but we are also thinking about focusing on rates and immigration, especially in California, because there are a lot of immigrants that are working in agriculture and also in Spain now. So something we're thinking about, but we're still defining the scope of the research. And yeah. Thank you.
So we quickly want to highlight how these all relate to the UN SDGs, which I mentioned earlier, is what we're guided by. So you go to the next slide, you see kind of the 3 main SDGs that we highlighted for the research projects this semester. We'll start off with the top. All these projects relate to making sure cities and communities all across the world travel sustainably with an environmental focus. All of them also focus on climate action, how we can take charge environmentally to make sure that we are going towards a more sustainable system. And lastly, a lot of them also integrated peace, justice, and strong institutions, making sure that environmental justice, in addition to sustainability, is centered in all these movements, and that moves into everyone and make sure that voices are heard in conversations around environmental initiatives.
So we post our results of our report on our website, which we made last year. It's surg.berkeley.edu. Okay, yes, please look at it. There's all of our research symposiums previously, which includes both Barsha and I's research last year. And you can also see previous SURG members' research as well. And there's also an overview about what SURG is, how to contact us, how to join. And this is where we're going to be putting our research in the future, as well as some research teams would like to try to get published in journals. So that's another thing we try to encourage and help as well. Cool. Thank you everyone for coming. Here's some ways to contact us. We give a big round of applause for everyone who did research today. We're so proud of you guys. Good job. Cool. Thank you guys for coming.
Can we get a SURG-wide photo if y'all can stay? Yeah. Also, I know that it's late.
Hi, Catherine. Thank you for coming.
Bye. Thank you.